are going to learn how to solve a quadratic equation by looking at the graph of the function. So what is a solution of a quadratic equation? A solution of a quadratic equation is also called the root or roots of the equation. These roots can be found by locating the x-intercept or intercepts of the function. Okay, those x-intercepts are also called zeros of the function. So if you look at your parabola, and we're going to look at this parabola right here, you are looking to see where does this parabola touch or cross the x-axis. And we will notice that it is crossing the x-axis at these 2 points right here. So there are two roots, meaning there are two x-intercepts or zeros, and there are two solutions to this quadratic equation. Those x-intercepts can be represented as ordered pairs. What are those ordered pairs in which the parabola is crossing the x-axis? The first one on the far left here was at -3, 0. The second was at -1, 0. So my x-intercepts are at -3, 0, and the point -1, 0, meaning my solution, or solutions in this case, are -3 and -1. They are the x value of those x-intercepts. Okay, when stating your x-intercepts, the y value of that point is always going to be 0. If we look at our second graph here, you will notice that it is touching the x-axis at this single point. Therefore, there is one root to this quadratic equation. That root is the x-intercept where it's touching the x-axis, and that would be at the ordered pair 3, 0, which makes the solution to this quadratic equation the x value of that ordered pair, which is 3. These last two examples show us exact roots of a quadratic equation, meaning that these parabolas are crossing the x-axis at integer values, meaning they're whole number values, positive or negative, okay? So when you have exact roots, we can use the graph of the quadratic function to find those solutions. But we're not always going to have exact roots. When the roots of your quadratic equation are not integers, we can estimate the solution by finding the consecutive integers between which the roots lie. Okay, so our parabola is not crossing the x-axis at an exact point that I can state. Okay, it's not crossing at one of our grid marks, so I don't know exactly where it's crossing the x-axis, but I know that it is. So if I look at this parabola, I can see that it is crossing the x-axis twice. So I know that there are two roots, okay? Now, even though I know that there are two roots, I can't state the x-intercepts because I don't know exactly what they are, okay? We can only state those if it is at an exact point that we can write down. Even though I don't know the exact value, I can make an estimate, or I can state a range in which the x values lie in between. Okay, so to do this, we have to figure out where is our parabola crossing over the x-axis. I know that it's right here and right here, but I don't know exactly what that x value is. All right, so we are going to make a table, and we're going to look at how the y value is going to change. So if I go ahead and fill in this table here, when x is -5, y is 1, which means when x is -1, y is also 1. When x is -4, y is -2, which means when x is -2, y is -2. And when x is -3, y is also -3, okay? Now, if I look at this table, we know that the solutions or the x-intercepts occur when the y value is 0. And we know y does not show as 0 on this table. However, we can notice that my y value goes from positive to negative when I switch from -5, an x value of -5, to an x value of -4. And I also notice that it switches from negative to positive when my x value switches from -2 to -1, which means those are my x values in which my solution lies between. So my solutions are x is in between -5 and -4, or x is in between -2 and -1. So again, if you cannot state the exact value, meaning that your answer for your solution is not an integer value, you need to state the range of x values that your solution is in between. Now, of course, we're solving equations here, so it's possible for an equation to not have a solution. So it is also possible for quadratic equations to have no solution, meaning there are no roots. This will occur when the parabola does not cross the x-axis anywhere. So, look at this graph here. Here's my x-axis. Where is my parabola crossing the x-axis? It's not. Therefore, there are no roots. There are no x-intercepts, and there are no solutions to this quadratic equation. In this lesson, we are going to learn how to solve a quadratic equation algebraically. And specifically, we are going to be using factoring and what is called the zero product property. So exact solutions or roots of quadratic equations can be found using factoring and the zero product property. You will learn 3 algebraic methods used to solve quadratic equations. The first is factoring in the zero product property. The second is completing the square. And the third is the quadratic formula. We will not be learning the last 2 methods during this lesson. So what is the zero product property? Zero product property says if the product of 2 numbers is equal to 0, then each individual factor can equal 0. Please note, your equation must equal 0 if you are using the zero product property. So from this first example, we can see that we are multiplying 2 factors, w plus 13 and w minus 9, and those 2 factors equal 0. Because of the zero product property, we know that our first factor, w plus 13, can equal 0. We also know that our second factor, w minus 9, can equal 0. Therefore, we are going to find 2 solutions to this equation. I will solve by subtracting 13. So my first solution is w equals negative 13. And for my second solution, I'll add 9. And my second solution is w equals 9. So this equation had 2 solutions, negative 13 and 9. So we're going to keep our focus on the zero product property. We're not going to worry about the factoring part yet. In this first example, we have 2 factors, 4y plus 8 and 3y minus 4. So because those 2 factors are equal to 0, we know that each factor can equal 0. So 4y plus 8 can equal 0. And 3y minus 4 can equal 0. We will solve each of these equations. For our first equation, we start by subtracting 8 from each side. So we have 4y equals negative 8. And then we want to divide each side by 4. So our first solution is y equals -2. For our second equation, to solve, we would add 4 to each side. So we have 3y is equal to 4, and then divide by 3. So y would equal 4/3. Okay, please keep in mind that if your solution is not exact, you need to write your answer as a fraction. Do not round any of your answers. Okay, for our second example here, you'll notice that there are 3 factors being multiplied: -3y, y plus 1, and 2y minus 5. So that tells me that there are going to be 3 equations, which is going to find me 3 solutions. So my first equation is going to be -3y equals 0, because that's my first factor. Next, I have y plus 1 equals 0. And last, I have 2y minus 5 equals 0. Okay, so we just need to solve each of these equations. So for my first equation, we divide by -3. So y would equal 0. It's my first solution. For our second equation, subtract 1. Y equals -1 is my second solution. For my third equation, I need to add 5. So 2y equals 5, and then I would divide by 2. So y would equal, you could use 5/2, you could use 2.5 in this case, or you could use 2 1/2, the mixed number, as your third solution. All right, so we know how to use the zero product property. Let's throw in some factoring, okay? Because the problems that you're given are not just going to be given to you in factored form. You are going to have to factor your polynomial in order to use your zero product property. So we're going to start with 2 examples that require we factor out just the GCF. So if I look over here at example 3, we will notice that the GCF of these 2 terms is p. They each have the variable p. So I will factor out the GCF of p, leaving me with the expression p minus 5. Notice my equation equals 0. That is a requirement for zero product property. So we have 2 factors, p and p minus 5, so we have 2 equations. P equals 0 is my first equation, and p minus 5 equals 0 is my second. This first equation is already solved, so p equals 0 is one solution. For our second equation, I would add 5 to each side and get p is equal to 5 for our second solution. Now on example 4, you will notice that my equation does not equal 0. And in order to use zero product property, the equation must equal 0. So the first thing that I will do is I'm going to go ahead and move this 27x to the left of my equation, which gives me 9x squared minus 27x equals 0. Now let's factor by finding the GCF. So the greatest common factor of these 2 terms is 9x. When I divide by 9x, I'm left with x minus 3 for my second factor, equals 0. So my 2 factors are 9x, so that would equal 0, and x minus 3, so that would equal 0. We'll solve our first equation by dividing by 9, so x equals 0 is my first solution, and then I will add 3 on my second equation to get x equals 3 as my second solution. Okay, moving on. Some more factoring. We're going to switch it up here, and we are going to be using the shortcut to factor a quadratic trinomial. So you'll notice here that our a values are going to equal 1, meaning that when we find our magic number, those 2 factors are going, the 2 factors of our magic number are going to become the 2 factors of our polynomial. So this first example is very straightforward. Notice the equation already equals 0. So our magic number is -54. And I need two numbers that multiply to equal negative 54 and add to equal positive 3. So my two factors are 9 and negative 6, which means the factors of my polynomial are k plus 9 and k minus 6, and that equals 0. Set each individual factor equal to 0 and solve. Example 6. Please notice on example 6 that the equation does not equal 0. So we're going to take this 5y and subtract 5y from each side. Make sure that you put your polynomial on the left side in standard form. So we have y squared followed by the minus 5y minus the 84 equals 0. My magic number is negative 84. What two factors multiply to equal negative 84 and add together to equal negative 5? That would be negative 12 and positive 7. So the factored form of this trinomial is y minus 12 and y plus 7, and that equals 0. Set your factors equal to 0. Y minus 12 equals 0. Y plus 7 equals 0. So y equals, add 12 to each side, 12, and y equals, subtract 7 from each side, negative 7. Okay, you'll notice on this next example, my lead coefficient, my a value, that first number in front of x squared, is not 1. So you should automatically tell yourself, hey, what's the GCF? Notice all three of my numbers are divisible by 2. So I have a GCF of 2, so I'm going to divide everything by 2, and that leaves me with the polynomial x squared minus 3x equals 28. Okay, now that I've taken my GCF out, you'll notice that GCF doesn't have any sort of variable attached to it. It's just a number. We can ignore it from now on, okay? So our equation must equal 0, so we need to subtract the 28 from each side. X squared minus 3x minus 28 equals 0. Okay, our magic number is negative 28. So what two numbers multiply to equal negative 28 and add to equal negative 3? That would be negative 7 and positive 4. So my factors are x minus 7 and x plus 4 equals 0. Set each factor equal to 0. Add 7 to each side for our first equation to get x equals 7. Subtract 4 from each side on our second equation to get x equals negative 4. All right, last example using our shortcut. Set up correctly to equal 0. So my magic number is 25. What multiplies to equal 25 and adds to equal negative 10? That would be negative 5 and negative 5. Notice your two factors are the same. So our polynomial becomes x minus 5 and x minus 5 equals 0. Remember, when the two binomials are the same, I can write this as x minus 5 squared is equal to 0. So I'm only going to have one solution for this equation. X minus 5 equals 0. Add 5 to each side. X is equal to 5 is my one and only solution. Notice that on example 9, our a value is not 1. It's 10g squared. So that tells me, hey, I can't use my shortcut here. All right, so let's start by just making this equation equal to 0 by subtracting that 29g from each side. So I have 10g squared minus 29g plus 10 is equal to 0. My magic number is 100. What multiplies to equal 100 and adds to negative 29? That'd be negative 25 and negative 4. So we're going to use our AC grouping factoring method here. So I've got 10g squared minus 25g minus 4g plus 10. Group the first two terms, group the last two terms. GCF of my first group is 5g, and when I divide by 5g, I have 2g minus 5 remaining. The GCF of my second grouping would be a negative 2. Divide by negative 2 leaves me with 2g minus 5. So my factored form would be 2g minus 5 and 5g minus 2. And that whole equation, of course, equals 0. So now I take my two factors and set them each equal to 0. 2g minus 5 is 0. And 5g minus 2 is also 0. So we're going to solve that equation. Okay, for our first equation, we would add the 5 to each side. So 2g is equal to 5, divide by 2. So g would be equal to 5 over 2. Same thing as 5 or 2.5 or 2.5. Okay, second equation, we add the 2 to each side. So 5g is equal to 2. You're going to divide by the 5, so g is going to be equal to 2 over 5. Or you could use 0.4 as your answer. In this lesson, we are going to learn another method of solving quadratic equations. And that method is to solve using square roots. So if I have the equation x squared equals 9, we know that the square root of x is the opposite of x squared. So to solve this equation for x, I would square root each side of the equation. So this gives me a solution of x equals 3. However, when I square root to solve an equation, so when I square root something being squared to solve the equation, I need to consider both the positive and the negative solutions that occur. So not only does x equal 3, but x is also going to equal negative 3. And we might be thinking to ourselves, why? Why does x equal both 3 and negative 3? Let me prove it to you. We said that x squared was equal to 9. If x is 3, that means that 3 squared is equal to 9. That is true. If x is negative 3, that means that negative 3 squared is equal to 9. That is also true. Let's try another example. If I have x minus 4 squared is equal to 25. This expression is being squared, so I need to square root each side of my equation to solve. Again, we have a positive and negative solution to consider. The x minus 4 could equal positive 5, or the x minus 4 could equal negative 5. Solve your solutions. Add 4 to each side. So x is equal to 9. And x is equal to negative 1.